Welcome to This Explainer, everyone. Today, we're going to explore something absolutely amazing. Have you ever wondered what exactly happens when you watch a video online or, send a message to a friend far away? Well, the internet isn't just invisible magic. It's actually a lot like a giant, super busy digital city. Think of the biggest real city you know. Our digital city is just like that. We've got wide roads, huge delivery trucks, busy post offices, and literally millions of helpers working day and night. Today, we're taking a tour of this digital city to meet the amazing helpers that make our computers work together perfectly. Okay, let's dive into this with a really big question. How do computers all over the world actually understand each other? I mean, think about it for a second. People speak so many different languages, right? English, Spanish, Japanese. But computers don't speak human languages. So how does a computer in one country share a picture with a computer in another country without getting totally confused? They need a shared language so everything makes sense. The answer is a pretty big word, but a simple idea: protocol. Now, protocol just means rules. Imagine a real city for a second. If there were no traffic lights, no stop signs, and zero rules, cars would crash everywhere. It would be a complete mess. A city needs rules to keep things moving safely. In our digital city, protocols are those rules. They're like the special jobs that help data, like your photos and favorite games, travel safely. By following these rules, all different types of computers can easily understand each other. So let's make our very first stop in the digital city the address office. Just like you live in a house or an apartment with a street address, computers have addresses too. If you want to mail a birthday card to a friend, you absolutely need their address so the mail carrier knows where to go, right? Well, computers work the exact same way. Every single place on the internet has its very own number so it can be found. Now, what's really interesting here is a helper called DNS. You can think of DNS like a giant phone book for the internet. When you type an easy name like youtube.com into your browser, DNS goes straight to work. It looks up that name and instantly changes it into a long number address. This number is called an IP address. DNS does this matching job so fast, you don't even notice it happening. It makes surfing the web super easy because you don't have to memorize a bunch of long, confusing numbers. But wait, how does your own computer get its address in the first place? Meet DHCP. DHCP is this super friendly helper who basically stands at the entrance of the network. The very second you turn on your phone or tablet and connect to the internet, DHCP runs right over. It automatically hands you a temporary number address. You don't have to push any extra buttons or do anything yourself. It just hands you the address so you can start playing games instantly. Now, inside a local neighborhood, like all the computers inside your own house, we have another helper named ARP. ARP is kind of like a friendly neighbor who shouts out the window. When your computer knows the number address but needs to find the actual physical device, ARP literally shouts out loud. He goes, "Hey, who has this IP address?" The correct phone or computer hears him and answers back. Then ARP matches them up perfectly so they can connect. All right, let's leave the neighborhood and visit the digital city's post office. This is where our messages, like emails, are handled. Have you ever sent an email? Just like a real post office sorts out envelopes to deliver across the world, our digital post office uses specific rules. These rules make absolutely sure your important messages don't get lost on their long journey. And this brilliantly illustrates how we have different jobs at the post office. First up is SMTP. This is the helper that pushes your mail away. When you hit send on a message, SMTP routes your email out into the world. But to get new mail into your house, you need different helpers. You use POP3 or IMAP. They act like your personal mail carriers. POP3 grabs the mail and brings it down to your computer. IMAP's a bit cooler though. It lets you look at your mail from your phone, your tablet, and your computer all at the very same time. Sometimes, though, an email is just too small. What if you want to move a giant file, like a huge computer game or a really big movie? For that, we use FTP. FTP is the big truck driver of the digital city. It's a massive delivery truck built specifically for moving heavy files between your computer and a big server. But there's one tiny problem with this big truck. It doesn't lock its boxes, so anyone looking inside the truck could easily see exactly what you're moving. And because some helpers don't lock their boxes, we need to visit the secret agent headquarters. Have you ever written a secret message to a friend using a special code? Well, in our digital city, there are sometimes bad guys who want to peek at your passwords and private pictures. So we really need special secret agent rules. These rules hide our information and keep it totally safe from anyone snooping around. The basic rule for looking at web pages is called HTTP, but HTTP is not safe. Using HTTP is kind of like sending a postcard. Anyone looking can read the words on the back. That's exactly why we now use HTTPS. Hear that S at the end? It stands for secure. HTTPS is our best secret agent. It encrypts your data. This basically means it scrambles your message up and locks it inside a strong digital safe. Only you and the website have the key to unlock it. We also have tools to remotely control computers that are far away. An older helper for this is called Telnet, but honestly, Telnet is a bit like a clumsy old secret agent. He accidentally drops his top secret papers everywhere and spills your passwords right out in the open. Because of that, we replaced him with SSH. SSH is like a fast, quiet ninja. It creates a highly secure hidden tunnel so you can control distant computers without anyone ever stealing your secret commands. All right, so we have our addresses, our post office, and our brave secret agents. Now let's meet the delivery drivers who actually drive the roads of our internet city. These are the helpers moving your data from one place to another all day and all night. We have two main delivery drivers, and they have very, very different driving styles. One is super careful. The other, well, he loves to go super fast. Let's see how they drive. So the crucial point is picking the best driver for the job. Our careful driver is TCP. It breaks your data into little packages and makes absolutely sure every single one arrives in perfect order. If it drops a package, it goes all the way back to get it. It's very reliable. UDP, on the other hand, is the super fast driver. He's a little messy. He throws packages as fast as he can and doesn't care if a few get lost. UDP is perfect for live video games, where speed is the most important thing, and a tiny dropped package is perfectly okay. Now, a big city with all these fast drivers and busy roads needs a great team to keep it running. Let's meet the background helpers, the city maintenance crew. These are the protocols that work quietly in the background. They make sure the digital roads don't break, traffic flows perfectly, and everyone is right on time. Without them, the whole city would just stop working. Here's the crew. First, NTP is the network clock. It makes sure every single computer in the city has the exact same time, which stops huge errors from happening. Next, ICMP is the traffic cop. It's our error checker. If a road is broken, ICMP reports the problem so we can fix it right away. Finally, SNMP is the city monitor. It helps the big city managers watch over all the hardware, keeping things like routers running happily and smoothly. Let's move on and see how this builds together. The digital city has literally millions of roads. So how does your data actually know which way to go? Well, protocols like RIP and OSPF act like clever GPS systems on a phone. They look at all the traffic in the city and then figure out the absolute fastest and best roads for your data to travel on. OSPF is especially smart for really big networks, making sure your favorite game never gets stuck in a huge traffic jam. It takes a massive team to keep the digital city running smoothly every second of every single day. So what does this all mean for you? Next time you tap a screen to watch a video or send a funny picture to a friend, I want you to imagine all those hidden helpers. Think about the address givers, the secret agents, and the fast drivers working behind the scenes, just for you. Which of these digital helpers do you think is working the hardest right now? Keep exploring, keep learning, and I'll see you in the next explainer.